All right, people. So I'm hello, welcome, whatever I might want to say here, introduction. All right. So you're looking at what you see to the right there. Once you look to the right, you see soil, and this is put on a Twitter account that does engineering post, and the people are saying, nice work, really nice work, etc. I'm going to show you. Well, it's not really nice work, not in the least. Totally contrary to what people were saying. Now spacing is nice. The rebar spacing, that's nice. I'm driving in a vehicle, guys, so I'm passenger, so you might hear vehicle noise in the background. I apologize for that. All right, so the spacing is, sorry, swallowing some gum. Very consistent, which is nice. Good craftsmanship. What I don't like is a couple of the rebar things here. But let's look at to your left. To our left of screen, where the rebar that comes down. Let me pull out. Let's get the mouse going. So there's some rebar that goes like this. You see that rebar there? It's right there, and it's consistently all the way down. So it's all the way down here. All those pieces, all the way down. Sorry, I'm being tossed around a little bit on the road here, so apologize for that. And the rebar is going, so you see it at the bottom on the floor, if you will, coming up, and then wraps around the back or the front of the street side, if you will, the walking side, not the soil side. This is all the soil side over here. This will all be soil up to there approximately. Depending on the surcharge, is it going to be level, or is it going to be go up higher, a little bit positive up. But that's not the only issue here. If you look at the reinforcement I just showed you, that roughly 45 degree stuff, which is here, it's on the rebar that's in the back from our position, from our view. And that's the compression side of this rebar. That is when the wall is experiencing a force or overturning force. That rebar that's here is in compression. It's useless up there. It's not quite useless, but it's not helping with the overturning, which would be more on this side. So you got the reinforcement goes up, it goes up again, and I know I'm showing you two pieces. That's the front and back wall, but if you notice, they use like a hook system right there of reinforcement, a staple, if you will. They went up and over. Let me get rid of it and show you again. So let's get rid of that. Let's zoom in, and let's get you a better detail of that. So there it is here. So it goes up and over, and it's consistent all the way down this, what I can observe. So it's actually two pieces of rebar, and then there's some overlap for this top section to help tie the front and back together. The front and back together of this system, well, it's minimal, the reinforcement. Now let's go to the overturning of it. Just thinking of it as being pushed, just pushing this wall. Don't think of the base yet. If you push this wall to the left, image left, so if I push it this way at the top, it will put this member, these steel, in tension. The backside is the compression members. It'll go in compression, and it's that rebar. It does give some stability. All right, we're not going to discount it totally, but this is the tension member. So what stops it from flipping over is its embedment and the weight of the concrete. In this case, like a gravity wall. They're using gravity because we see that. When I say gravity, I don't mean it's. I believe in equilibrium. Everything can be justified through equilibrium and magnetism. So I'm just using the general term gravity, which you guys know as dead load. Might call dead load, the weight of it. So the concrete comes here on top, comes over. Sorry, I did a little wrong. So let's try it again. Comes over, it goes up to there and over. All right, it's back down again. All right, and then it comes over the base again and up. Okay, so it looks like that. It's sort of profiled. Now, what I want you to observe is that the base. After I do that, hold on, let me get rid of it. So let me continue what I was saying. As you push on this wall, the embedment of the concrete that you just poured, the concrete that was just poured, let's go this way. I'm driving, guys. I'm telling people which way to go. So the embedment is the, let's get this embedment, is that concrete down here. All right, the weight of it, if you will. That's weight. Why do I say weight? Because there's nothing locking this in. I want you to now see it now. It appears to be concrete, that they've set this new rebar caging reinforcement up on top of concrete, just sitting on top. But what are they missing there? A keyway. There's nothing to stop this from sliding off. So the soil, the weight of the soil and water, etc., can have this slide. And if you look at it, it looks like it's on concrete. Now you can. I really look for plywood on this. Try to see, is that plywood at the bottom? It still would work against you even more. This is concrete, and so we can't see what's below this concrete. But it should be a keyway. That is, it should key into the soil. So let's see if I can get you a sort of an image of that. So let's use the pad. So the pad should be something like this. And this is keywayed into the soil. And then your new system going on top is like that, right? Let's do this. And you can see right here where they keywayed the pad, because you see it out. Wait a minute. You don't see it out there. Oh, okay. So then they put it over here. Well, no. Oh, okay. So they didn't use it anywhere. It's the way I teach, guys. So let me play. This is. I want you to be, to learn better that way. The way I do it, so you can. So this whole top section can just slide on the pad. I don't care if they keywayed the bottom or not into the soil. They still can just slide off. It defeats the purpose of, if this was keyway down there, or is, it's still useless. You don't see any keyway of this whole top pad surface. Nowhere do you see it drilled into the concrete either, epoxy, doweled, etc. If you look to the left, it's actually turned up. They have legs on the bottom of that reinforcement I just talked about that would be in tension. Small legs, little 90s. And it is not doweled. And if you look at the other one behind in the back wall, it's also turned like that, not doweled. And that's consistent all the way down. So no, this does not pass muster as a retaining wall. It can slide. Yeah, I know it's a lot of weight, right? Plus the weight of the soil on it, but that's not the way it works. The heaving of is amazing what soil can do. You've seen it push houses down. A house by itself can push down a hill, retaining walls and all. Swimming pools get pushed down the wall with all that weight on it. They still get pushed down the slope of a hillside. So it's not the way it works. So that weight of the soil on top can act as one and magnifying, or I like to say force multiplying the current weight of the concrete pad. The extra weight of that soil, it would possibly become one. Now I'm not sure the intent of these here. They don't go all the way through, so it could be a simple. It could be an opening for gutter. If they went all the way across, I'd say it's expansion joint, but they do not. They stop apparently like right there, and I don't know if there's more of them down there and there's visual in, but yeah, I don't know if it's drainage or not. It allowed water to come down and escape through the face, and which would just put water on the other side of the wall. You'd have to make sure you keep continuing getting that water off, running it away. So yeah, the reinforcement's nicely spaced, but there's a few negatives I don't like, and I talked about that keyway specifically. And let's go ahead and end this video. But I thought I'd find you one more image before I end it, and that's also the way I like to do my videos, pretend like I'm ending and not. You see this one? It's all continuous pour, and it's keywayed. And it's referred to here as a shear key. Shear key. I have a little grammar issue there, don't I? A shear key, and that's going to stop your sliding. And of course, that's based on the depth and your weight, etc. It's all calculated. You take it into consideration. And as you can see, the key is on the other side of this wall. So that's why maybe they did the same. I doubt it. I really doubt it. Just because I don't see a keyway for the retaining wall part of this system. The part that we look like they're going to pour next, that we all observe to look like they're going to pour next. So again, in conclusion, we have this, I apologize again for the vehicle noise, but you know, I don't get paid for these videos. I just put them up for you guys. We have a system that can just slide. All right, it's lacking. If they would have keyed it and put rebar down in that key, so it lock and just doesn't shear the key. You know, if it's just concrete, and then you try to just transition up, well, the concrete can just fracture itself. And then you got to worry about expansion in it also. So it'd be a kind of a really good, nice technical key to make. You know, it's got expansion and contraction, thermal differences. So you'd have to resolve that through reinforcement, through isolation from the water, and or compensate for the water and allow the expansion to take place with the freeze thaw expansion. And I don't know where there's, you know, it could be a place where it doesn't freeze at all, and then it's just heat-related thermal expansion. There could be some curling type problems too, but I don't think so. I don't think they'll have that. All right, take care, and love you guys. Thanks for watching, and hopefully this was informative to you. Again, that reinforcement on the right side of that wall, at the tension side that gets put when the wall gets loaded. That's the one that this reinforcement, oops, trying to get my thing up, my little pen up again. There we go. That this one should have been more on that one like that, and develop it more. They could probably roll it back also to tie in the wall a little bit, but this is the one that's going to be in tension, trying to roll over this one there. And that's the one that they did not tie into. They put it in the back one, and so it's going to get some concrete, some little interaction there, you know, slight interaction that won't mount to much, but this placement should have been in the front. If you're going to do this, develop this longer, and develop this one longer too, and like I said, maybe turn it. Okay, hopefully this is helpful for you, and take care, guys.